Hello everyone, my name is Ateeq. I'm the product manager of ProtaSteel and I'm also the general manager of Prota Software. We'll be having a seminar about ProtaSteel, which is the automated connection design and steel detailing solution we provide. Today, the topics we will cover include our macro libraries, which we'll be talking about in detail, the production of assembly drawings, the connection calculation reports, which are a great feature for consultant firms, IntelliConnect, which is a revolutionary feature we have in ProtaSteel, which is going to help you in detail your buildings extremely quickly and without effort. We'll be talking about IFC and Tekla Integration. We'll be talking about the advantages of ProtaSteel in the industry and the future of steel design. So let's see it in action and let's have a demonstration. You're familiar with ProtaStructures. What is ProtaStructure? ProtaStructure is the ProtaStructure suite is the suite which is used in the construction industry for the analysis and design and detailing of multi-material structures. So whether it is steel or whether it is concrete, ProtaStructure can be used to analyze the structures, design them, and then also detail them. The screen you're seeing right now is the ProtaStructure screen, and as you know, you're very familiar with this. What I'm going to show you today is how you continue with your structure, the detailing of your structure in ProtaSteel. So the idea is that once you're finished with the analysis of the steel structure inside ProtaStructure, you transfer to the detailing side of things. So you basically go and you say load ProtaSteel. When you do this, the structure which you have created in ProtaStructure, it's transferred to ProtaSteel. And it's not only the structure which is transferred, but also the loads inside the elements, which will then be used in the analysis of the connections and the design of the connections on ProtaSteel side are also transferred. So once you do this, you'll be facing the ProtaSteel screen, and this is what it looks like. And I'm going to be talking about this program today primarily. We'll be together for almost an hour, and we'll go through all the basic features, and I'll try to show you some of the exciting stuff which we are doing. So, like I said, the basic philosophy is you input your structure in ProtaStructure, you input your loads, you input your load combinations, you design the structure over there, and once you're happy with the design, once you're okay with the sizes of all the elements, you just transfer your steel structure into ProtaSteel. It's going to come, not only the steel is going to come, but also the concrete will come, so you'll be able to see the entire structure over here. And once you're here, then you can start detailing the structure. The purpose is to detail the structure, to produce connections, to produce connection drawings, and to produce shop drawings. This is what we'll be talking about. So once you're here, as you can see, the structure is primarily unconnected. There is no connection. The purlins are there, but they're not connected. The girts are there, but they're not connected. The sag rods are there, but they're not connected. The beams, the columns, they're all here, but there's no connection. And this is the first thing which we want to do. We want to make the connections. Now, ProtaSteel has a very advanced library of connections. I'll quickly go over the list of these connections to give you a better idea of what we're talking about. So we have flooring connections. We have beam-to-beam connections. These can include the stiffened end plate connections, for example, or they can include the beam-to-beam end plate connections. They can include the fin plate connections. They can include the angle cleat connections. So different types of floor connections, which are basically there to connect a floor beam to a floor beam, and the connection is a simple connection, so it's a hinged connection. Then we also have a suite of connections which are there for making moment connections or simple connections between the beams and the columns. So they're beam to column simple connections. Once again, you have the end plate connections, stiffened end plate connections, fin plate connections, but you also have the moment connections to connect the beams to the columns. And you have your truss connections, you have your bracing connections for the vertical braces, you have the connections for the horizontal braces, you have connections for the roof braces, So basically, the entire structure, which you're going to detail, you will, in all probability, like more than 95% of the times, you will have a suite of connections over there on the top of your screen over here, which will help you very quickly model the connections. I'm just going to go through these connections manually so you can see. You'll be able to see how quickly we can do that. But in the beginning, I just want to mention that you will have this suite of connections. And the next thing I want to say is that if at any point you need a special connection, you will also be able to do that in ProtaSteel. I'll come back to that later. So now let me do what I just told you manually, so that you have an idea of what we're talking about. Let me go on the other side, spin the building around, and make a few connections. So I'm going to go to the purlin connection over here. And I'm going to say I need a connection between this truss top cord and this purlin, and the connection is made. I can go inside the macro. I can reverse the direction of the cleat if I don't like it. I can make a different connection. For example, if I don't want the angle cleat connection, I can make the bracket type connection. I can make a folded plate connection, for example, over here. So so I can make a folded plate connection if I want. If I want, there are several, about 5 or 6 options inside, which I don't want to go through one by one, but there are about, so within this macro, within this single button, you have about 6 different kinds of connections, which will help you connect the purlins to the roof beams or to the trusses. Now the same button which is there to connect the purlins is also used to connect the girts. So for example, if I were to come here and select a column and select a girt, I can use the same connection to make the connection for the girt as well. I can choose a different type over here. For example, I can say a bracket type without cut, and if that's what I want, then I'll prefer that. I can then use, this doesn't have to be a single-sided connection. I can use the same macro to have a 2-sided connection. And once again, I have all my parameters to choose from, which I'll just do over here. So some of these connections are more suitable for girts. Some of these connections are more suitable for purlins. But the idea is that just by clicking this single button, you can create a host of connections for both purlins and girts. So if you're maybe thinking that the number of connections over here doesn't seem to be too many, the answer is that they are sufficient, and the reason for that, the reason why the number of icons is not that high, is because a lot of these connections cover multiple cases, which will become an added benefit as you will see. So let's show you some other fees. For example, if I have an apex haunch over here, if I go to my apex haunch connection, I can just go and click. As you can see, it's as easy as just clicking the main and secondary members, and the connection is created automatically. Let me do a few beams with horizontal bracings in there as well. So let me just go in there, zoom in a bit, and see what we have over here. So let's create a connection over here. Let's create a stiffen end plate connection, for example, between this beam and this beam, and we have a stiffen end plate connection. What if we wanted to connect, make a beam to beam end plate connection? Then that's also available. If you wanted to make a fin plate connection, for example, between this beam and this beam, that was also possible. And then we could then use other connections to connect these horizontal bracings as well. I'll talk about them in a minute because they're a little more complicated. Let's go and make a few connections regarding the columns over here. So let's make a connection over here. This is going to be interesting. So let's make a haunch connection over here. We have a haunch connection, and now this haunch connection creates some stiffness at the back, which are creating a problem for this incoming beam from the other side. So I'm going to create a stiffened end plate connection from the other side. I'm going to say there's a connection between the column and this beam, but this connection needs to take into consideration these existing stiffeners over here. And I'm going to select those 2 stiffeners, and I'm going to ask the program to make a connection. And as you can see, it has modified those stiffeners to suit the connection from this side. And as you can see, the connection was made quite easily. Now we have a brace coming in over here. Let me just go and create a corner bolted connection. I'm going to select the column, I'm going to select the brace, and I'm going to select this this stiffener as the end, and as you can see, the program automatically makes the connection. So this very complicated connection, which required some connections to use elements made by other connections as part of the design, are being created so easily. And the other side, I can go and I can create, for example, I can go to this side and I can create my beam connection with the column with these stiffeners, and it's as simple as that. So this very difficult joint, as we can call it, which has incoming beams from both sides, which has a vertical bracing coming in as well, is easily modeled with a few clicks of the mouse. I can go and make some other connections. I don't want to go very deeply into all the connections right now. I just want to give you a taste that we have floor beam connections, we have beam to column connections, we have purlin connections, sag rod connections, we have splices. So for example, if I want to create a splice between this column and this column, it's easily done. This splice can work with all sorts of other profiles as well. I can create, for example, if I were to create a floor stud connection, for example, over here, I can just select this beam and I can create some floor studs over there. The shear studs will be there for the concrete floor, which is going to be poured later. I can change, for example, I can go in there, I can change the type of the stud. If this basically looks at my library. I have a library of different studs which I can create, and then I can use those to model the shear studs. Now, I'm going to start talking about one feature which we have added. I had mentioned that we use these connection macros to detail and also to design the connections. Now, as you know, the different programs give detailing options, but very few detailing software give the option of producing design reports. So what ProtaSteel does is what we've started doing is we are starting to produce design reports for various connections. So at the moment we have the simple connections built in. So we have the connections for the floor beams, and we have the simple connections for the columns. So for example, if I were to go in there and let me just show you a bit of that. Now, before what I want to show you is actually I want to start all over again from it looks more impressive. I just want to show you. So when we're in the model, what we can do is we can turn on the connection design ratio coloring. So if we turn this on, the entire structure turns white. And with this option turned on, we can now start connecting the structure. So let's, for example, if you were to connect this beam with the stiffened end plate connection, if I were to go in there, for example, and say that connect this to this, you immediately see that the connection is created and it's green. This green color coding tells us that it has been designed according to the loads which were transferred from ProtaStructure. And those loads have been taken into consideration. And the number of bolts, the thickness of the plates, the sizes of the welds have all been designed by ProtaSteel. And if we wanted to, we could select this macro button and ask it for the default connection report. If we do that, we see that a report has been prepared by ProtaSteel, which gives the detail of the incoming beam and the main beam and the secondary beam and the sizes, the end plates, the back plates, the welds, and it gives us the different design checks which it has done and which the design passes. And you see these green labels over here, pass, 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 which is basically telling you that these connections are safe. And if that was not to be the case, so for example, I'm going to do another example in which the connection is not suitable. So no matter what it does, it can't design a suitable connection for that point. What it will tell you is that this connection is not suitable for that. So I'll try to use a fin plate connection over here in this beam, which has a slightly large load. So let me just do that to begin with. And do that, you see that automatically the moment you do it, the connection turns red. So there are two modes basically. Whenever you make the connections, whichever connections support this design feature, like I said, at the moment it's the simple connections for the floor beams and the simple connections for the columns. And I'll be talking about what's coming up ahead in a moment. But whatever connection you use, you will get this color coding immediately, even without creating the report. So you don't need to create the report to see the color coding. You can just go ahead, make the connections, and as you make the connections, you will see them turning either green or red. And there's a third color, which is yellow, which means that that particular connection at the moment in ProtaSteel does not give you the design report. So it's not checked, so it'll be yellow in that case. So if that is used, you will see a yellow color. So for example, just give you an example of that. If I were to make a base plate connection over here, for example, it will turn yellow. It will not be either green or red. What that is basically telling you that currently this base plate connection is not designed, and you need to check it yourself. So the basic idea is that as you use these connections, you will see them color coded as long as this view is on. This color coding is on, and once you're happy, once they're green, if you want to check, for example, why something is red, you can go and create the design report and see which particular part of the connection is failing. So you will see that, okay, it's passed some of the tests, but some of the tests are failing inside, and you need to go and make a change in that. Now, when we introduced ProtaSteel, we had, let me just go back, we had several connections which were already there, but now this year we have introduced some new connection macros. Now, the most prominent among these are the apex haunch macro, which creates the apex haunch connection, and this is very commonly used, so it was a need. Another connection which has been added is the apex truss connection. So although we had other truss connections, so we had connections like to connect the trusses, we could simply use the bolted gusset or the welded gusset connection. For example, we could say that we have the stop cord and we want to connect it to these secondaries. We could create a connection as simply as that. We could do this and to make another connection. But what we didn't have was this point, and we have, for that, we have introduced this new connection, which now enables us to create that particular point as well. And another connection which was missing was the truss end plate connection, and that was primarily for situations like these, where there's a truss top cord and there's a diagonal as well, which are framing into a column, and we could use this connection. We can now use this connection to make this connection over here. Another thing which we have added is which is not fully finalized at the moment, but it's almost there, is the base plate connection with design. So what I showed you at the moment was the base plate connection without design, but right next to it, this is generally, you can basically model anything you want with it. So it's quite a complicated connection. You can put all sorts of and there's a lot of variety you can do over here. But we have, upon the request of some of our users, what we've done is we've created a simple base plate connection for simple hinged columns and simple fixed columns, and this one also has the design feature. So with this one, you can design your simple columns, small, not large columns, not columns very large loads, in which case you need to design them yourselves at the moment. But at the moment, if the columns are simple and straightforward, you can create the simple base plate. You can use the simple base plate connection macro, and it will design the connection as well. Another connection which we've added is the angle cleat connection, and which is the fourth type of floor beam connection, which can be now used in ProtaSteel. And upon the request of some of our users, what we've added is the handrail connection, because this was a beam, and you can bypass the point selection, and you can basically create handrails in different parts of the structure. And we're going to keep adding to this list, already extensive list. We're going to add some new connections this year as well. Like I said, but primarily our focus is going to be on completing the design reports. So what you can expect in the future is that that the design reports for the moment connections between the beams and the columns will be available by the end of the year, and that will be a big improvement, because now you will have the base plate connection which is being designed, and all the beams and column connections are going to be designed, all the floor beams are going to be designed. So that will be a big help. And what will be left at the end of that will basically be the secondary connections, like the horizontal bracings and all. We want to immediately after that tackle the main vertical bracing problem. The only issue with that is that although it's actually simpler than the moment connections, but what we need is there's a lot of variety in the types of profiles which can be used and the types of connections which can be used. So those will come later. Now, what I want to talk about now is the connection drawings. Now, as you know, what was the reason why we're using ProtaSteel? There are two basic reasons. The first reason why we're using ProtaSteel is for the connection, for the production of what we call connection drawings. Now, what are connection drawings? Connection drawings are the drawings which are prepared by consultants. So let me just give you an example. Let me just open another project over here. Yep, I think this is the one. So here's a fully connected building. We were just going over a few things as we saw. This is a fully connected building with all the, let me just remove the clutter so you can see it more easily. Points as well. So yeah, so as you can see, this building has been fully connected, and as the consultant can now use this model to produce what are called connection drawings. So you see these little boxes over here. These little boxes basically represent different areas of the structure which you want to show to the client or to the company which is going to do the detailing and the production of shop drawings, to the manufacturer, for example. That these are the connections you want, and for this you prepare what we call connection drawings. So let me go to the section over here, and so before I go there, I'm not going to be talking about these little boxes over here. These little boxes you create very easily. That it takes hardly a few minutes to prepare these boxes. What they tell you is that I want to prepare the connection drawing for this area and give it to the client. So I go to the drawing side and I open my drawings and I just do, for example, grid A. That's the general arrangement drawing. So this is the general arrangement drawing. Those boxes which you just saw on the other side will appear on this drawing as circles. So they'll appear as circles, and this will tell you that this is what you want to show, to give the detail of in your connection drawing. And for that, all you need to do is just press this very simple button over here, which has been created to automatically produce the connection drawing. And when you do that, in a few seconds, the program will create these connection drawings. So it'll go and it'll create different views of the connection from top. This is all customizable, so you decide whether you want a 3D view in there or not, whether you want a top view in there or not. But once you've decided on that, then you can use these drawings and send them to the client or send them to the manufacturer for whatever purpose they're going to use it for. I told you that the creation of these boxes is extremely easy, so I just want to show that so that it's not left unaddressed. So let me just do a quick box over here. So I can go over here. I can, for example, make a splice connection like this. So I'm going to just now select these elements over here. I'm sorry, not the incoming. It's just the elements which are part of the connection. I just press this button on the modeling side, and I give it a name. Let's call it test, and I add this. And when I do that, I select objects. Once I'm done with that, it asks me to select the secondary. When it says secondary objects, what it means is the objects which are not part of the connection itself. So those are basically the columns over there, and I press that, and I give it a right click. And the moment I do that, it creates this little box around it. And once this box is created, you can then easily go to the drawing side and make an automatic connection of that, automatic drawing for that. So it's as easy as that. You make a complicated connection. The reason why we don't use create these boxes automatically is because lots of joints, lots of places actually require multiple connections to be made, but they need to be a single box. So for example, if we were to make a haunch connection over here, and then make a stiffen end plate connection from the other side, like this, and then make the corner bolted connection like this. So we can select the column and the vertical bracing and the. So this now when we want to produce the connection drawing for this whole area, so it's actually multiple connections which need to be modeled, and now we need to put a box around the whole area. So that's why we don't do this automatically, but we leave it to the user. So the user can basically select any elements in the model and then create a connection box. And once the box is created, then that box can be used, like I said, for the preparation of drawings. Now, this is the first main usage for consultants. Let me go back and show you a few other things. What is the second most important usage of ProtaSteel? The second most important usage of ProtaSteel is the production of shop drawings. So if you're a consultant company and you're not in the business of the production of shop drawings, you can add that to your portfolio. What you can do is you can produce shop drawings at a click of a button, and that'll be done so easily that you can even sell these drawings to your client with very minimal extra effort, because you will have done the main modeling work anyways through the ways which I just showed you. And once the model is completed, you can go ahead and just at the click of a button, you can produce shop drawings. It's as simple as selecting whatever parts you need to draw, and you just right click and you say create drawings, and you can create part drawings, and you can create assembly drawings. So you can create drawings for each individual part, for each plate, for each beam, for each column, and you can also produce a. Now I'm going to take you to the drawing side and show you some of the results over there. So for example, if I show you this one, this is the truss, and I'm going to open it. Opening it takes a while because it's a complicated drawing. It's got almost 96 viewports inside it. It's looking at all the plates in the truss and all the profiles and all the, of course, the main truss assembly itself. So this is the assembly drawing for the truss, and it's going to open in a second. There we go. So as you can see, with a click of the button, we can create the shop drawing for the truss. And as you can see, it's been beautifully detailed, almost as if it was done by hand. But if you don't like it, if you want to add a dimension, if you want to remove a dimension, if you want to add some details, or if you want to add a few texts, this completely independent drawing editor will allow you any kind of modification in this drawing. So the material lists are also there. The single part drawings are also there. The title block is also there. You can basically play with this. This is all customizable. This is comparable with the world-class software which is used in the market for the production of shop drawings. And what it will do is it will save you man hours. So let me show you another example of a beam over here. This is the beam with the haunch connections on both sides connected to the column. And we will go in there, zoom in there, and see what kind of drawing we have. So as you can see, these drawings are very neatly produced drawings with all the details of the welds and the bolts and the location of the bolts and the location of the welds and the basic dimensions of how the manufacturer is going to manufacture this beam are all given. And this is not done manually. This drawing is completely prepared by the program. And anything which you see on the screen, like the annotations and the sizes of the fonts and the colors, and or basically any detail to do with the drawing itself, it's all customizable. So it's not that you will only get this particular format. If you don't like it, you can change the format. It's completely customizable. There's a lot of if I were to show you, for example, yeah, there's a lot of parameters. I'll just to give you a hint. So all these settings can be changed, and you can create a completely different drawing if you wanted to. There's a lot of detail in there. I don't want to go into that, but it's what I want to emphasize is that it's customizable, and you can produce the drawings according to your local standards. Now, let me get back to the modeling side of things. Now, it might be a bit challenging for consulting because they might be thinking that we are not into the 3D modeling business. We are primarily consultants, and we find this whole business of making connections a bit daunting or a bit overwhelming for us. So what I want to emphasize is that I already showed you how quickly the user can make these connections. But what I want to emphasize now is it's even faster. It's even faster than what you've already seen. What I'm going to introduce you to is this revolutionary new idea of what we call IntelliConnect. What IntelliConnect does is it takes into consideration each joint. Now, when I mean a joint, what I mean is, so over here we have a joint. This is a joint. This is a joint which has several incoming elements. So there's a column, but there's a beam coming from this direction. There's a beam coming from the other direction. There's a vertical bracing coming. So it doesn't basically look at 3 or 4 different connections over it. What it does is it assumes one connection which needs to be made, and this connection needs to take into consideration the constraints of all the other connections. So this is what IntelliConnect does. It takes the whole thing into consideration and produces for you, or tries to produce for you. I'm not going to say it works 100% of the times. Mostly it will work, as you will see in a moment. What it tries to do for you is to create a clash-free connection. Other programs which use something which is called AutoConnect have a completely different philosophy. What AutoConnect will do is it will create the connection of this beam and then create an independent connection for this other beam, and these two will be completely unaware of each other. And what will happen is that there will be clashes. And once you're done with the AutoConnect, you will have to go back to each and every joint and start the cleanup process. And this is what takes time. So the whole idea of AutoConnect basically fails. What we have attempted over here is IntelliConnect. And what IntelliConnect is, it potentially tries to solve some of these very complicated questions. I'm going to start off with a few examples. So all you need to do is just select your entire structure. You can select a part of it if you wanted to zoom in and do it slowly, which is also recommended. But if you wanted to select the entire structure, you could just select the entire structure. You do a right click and you say IntelliConnect. And when you say IntelliConnect, you're given different options. So you say, I want to connect the purlins first. So when you select that, it gives you the different options. So this also helps you in the training learning curve as well, because a lot of people say that there's so many connections, how will we learn them? So IntelliConnect basically takes you through these steps as well. So it says you want the angle cleat connection for the purlins. You select that. You can use the folded plate. You can use the bracket type, whatever. So I'm going to choose the angle cleat connection, but I don't want the angle cleat to be on this side. I want to reverse. So I want it to be like this. This is what I want. And at this point, I'm done with IntelliConnect. I want it to find. What I want the program to do at this point is to go through the structure which I've selected, find the joints in which there are purlins, and leave the others untouched. Look for the purlins and connect the purlins according to this particular connection which I've set up. I'm going to just press run now, and as you can see, there's a progress bar over there. It's going to take a few seconds, and what you see is a report at the end. It says node number 2583, it's connected. Node number 2584 connected. Node number 2585 connected. As long as you see it done over here, it means that the IntelliConnect feature was able to connect that part. If occasionally you will see could not connect, it's all done in this case. But sometimes you're going to see could not connect. And in that case, you will have to go and do that particular node yourself because there's something different about it which the program couldn't do. So let me go and zoom in over there now. And I can, as you can see over there, the angle cleat connection has been made, saving you of so many man hours of time because you would need to spend some time on making these connections. Consider this to be a much larger building with all sorts of different areas, and you would be doing all of that manually. But as a consultant, in a few seconds, now you can create all these connections and then go ahead and make the shop drawings like I showed you a while ago. Now I'm going to select the whole building again, but this time I'm going to go to IntelliConnect and ask for it to make the girt connections. But this time I want to use the bracket type without cut. This is the one I want to use. And I'm going to say run. Once again, the program goes through the entire building, and at the end it says, so these are the simple cases. Actually, I'm going to get to the more complicated cases as we go along. But what I just wanted to show you was how quickly, how completely easy it is, even for someone who's not very familiar with 3D modeling. So it's automatically detected that this particular joint required a two-sided connection because there were two girts coming in. But this particular one needed a one-sided connection because there was only one girt coming in. So all that stuff, all the intelligence is built into the command. Let's do the base plates, for example. So I'm going to just select the entire structure again, and I'm going to right-click. I'm going to say IntelliConnect, and I'm going to say create the base plate connections. Now, okay, let's do that. Now, they've all been done. A little difference over here. These columns are the same. These columns are the same. But the columns over here had a fixed connection at the bottom, but the columns over here had a hinged connection. So it noted that, and it chose the appropriate connection, although it was the same connection in the background, but it modified it to give you a hinged connection for the hinged ones and a fixed connection for the fixed ones. Let's do another case. Let's select the whole building again, go to the IntelliConnect, and ask for it to make the splice connections, for example. Once again, it's all done. It's mostly going to be, for all these cases, it's going to be, you will 99% of the times you will see a report like this, which is going to save you a lot of time. Now, we can do the sag rods, for example. I'm going to go through and do the sag rods now. Let's go to the sag rods over here. There's so many, takes some time. So it's gone in, it's done created the holes for the sag rods and extended them, and so yeah. So it's as simple as that. Now I'm going to do a few of the very difficult connections. I'm going to ask the program to make the floor beam connections. So as you can see over here, we have some floor beams and we also have some horizontal bracing coming in. Now, these are what we call the floor beams connections, and these can be of different types. So I'm going to just go and select the building. I'm going to say IntelliConnect and create floor beam connections. Or let's do the truss connections first because they could be easier. Let's do the truss connections first. And it asks for a gusset plate thickness. I don't want to give it. I want it automatically from depending on the twin into twin distance. I'm just going to say run. It's going through all the trusses. Yeah, as you can see, the screen is updating every now and then. There you go. Let's go to the other side. So here we have your trusses connected. So as you can see, it's hardly been about 10 minutes since I've started doing this IntelliConnect demo, and in 10 minutes I have managed to connect almost most of the building, in fact. And I've left the two most important and two most difficult cases for the end. because those are the ones which will really make you appreciate the value of IntelliConnect. I'm going to do them now. I'm going to select the building again, and I'm going to go for IntelliConnect, and I'm going to say create the floor beam connections. So like I said, the floor beams were the ones over here where you have the floor beam connecting into a floor beam, but you could also have or not have, depending on the case. You could have your horizontal braces coming in, or you may not have the horizontal braces coming in. So it'll automatically search for the best answer. So create the floor beam connections. Now it asks me which floor beam connection do you want to prefer. So I say I want to prefer the stiffened end plate connection, for example. I have the option of using the fin plate also. I can even add the fin plate. I can say if you don't find a solution with the stiffened end plate, then try the fin plate connection. And if that doesn't work, you can try the end plate connection. So this is the way you basically select or deselect what connections you want in the scenario which IntelliConnect is going to use, and you can make it more complicated. So normally the way it would go is you would, as a consulting company, you would prefer a particular kind of connection for the selection, and you want to use that as much as possible. But then you also know that in certain cases that won't work, so you want to have an alternative backup. So you can say that, for example, okay, use the stiffened end plate as long as it works. But if it doesn't work, you can go to the fin plate connection, or you can do it the other way around. So I'm going to just stick with a simple case right now. I'm going to say use the stiffened end plate connection. And when I do that, it says, okay, but these are floor beams, so there might be horizontal braces coming in as well. What do you want to do? So I tell it that, okay, I want to use the corner gusset connection, corner bolt gusset connection if possible. But if that's clashing or there's some problem, then I want you to switch to the bolted gusset plate connection, in which case you might need to shift the horizontal brace a bit. A lot of flexibility over here. I'm telling it what type of floor beam connection to use. I'm telling it what kind of horizontal bracing connection to use, and I'm even giving it some shifting parameters. So when I go next, it asks me about the shifting parameters. It says, okay, just in case I need to shift the horizontal bracing, is there a maximum limit you want to put on this? Do you want me to go as much as I can, or as much as I need to, or do you want me to limit the maximum shift? Stuff like that. So I'm not going to go into those details, but what I want to show you is once you press this run button, the program starts connecting the floor beams. And it's going to need to shift some of the horizontal braces because I've selected a very difficult connection, the stiffened end plate connection, which usually will require some shifting of the horizontal. So this is going to take a while, but it's still like within a minute in all probability. There we go. In some places it said was not able to connect, so we'll need to check those. But in a lot of places it made the connection, as you can see over there. I'm going to do the final bit, which is the most difficult one. I'm going to do these connections over here. So there's a fixed connection coming in from this side. There are hinged connections coming in from the other side, and they've got vertical bracing in as well. So those are what we call the column beam connections. And these are probably the most difficult connections to make. What I'm going to say is I want a haunch for the fixed ones. So I have different options. I can use the haunch. I can use the flange plate moment connections. I can use the directly welded connections. I can use the extended plate moment. These are moment connections, but I want to use the haunch in particular in this case. And for the floor beaming, I want to use the stiffened end plate rather than the fin plate or the end plate, because this will give me a stronger connection over there. And if there's a vertical brace involved, I have certain parameters. We can get into those later, but I wanted to try and make the connections. Okay, so I'm just going to go over a few. As you can see, I had done this manually at the beginning of the demo. I had made this haunch connection. I had made a connection from the other side, considering these two stiffeners, and then I'd used those stiffeners to produce this corner connection over there. As you can see, it's done all that for me automatically. this is an innovative technology, because what this tells you is that the program can detect one connection. It can detect the elements created by that connection. It can see that those elements might be a problem for the other connections, and then use those particular ones or delete them in certain cases and make a modification, or use them directly to basically leave you with a connection which is final, which you can just use directly. There's no clash in there. Nothing is clashing with anything, and everything seems to be like perfectly fitted. So this is the idea of IntelliConnect. This is what IntelliConnect does for you, and this will. What I want to emphasize again and again is that consultancy companies usually are quite overwhelmed by the challenge of 3D modeling. And what I want to show you was that this feature, IntelliConnect, and in general the general way in which ProtaSteel handles the steel will make it a breeze for you. It'll be extremely easy, and you've seen it on the screen yourself. It's not that difficult. All you need to do is get a little training, get started, put a few man hours into the training, and you'll be up and running and very quickly, much more quickly than other software. You'll find yourself not just finishing the analysis, not just finishing the design of the structure, but also finishing the design of the connection, and also finishing the shop drawings, and also finishing the connection drawings with very little extra effort. And that's going to be a huge advantage for the company. I'm going to give you an example of the copy feature of ProtaSteel. So let me go to this building over here. It's an interesting feature because once so this is a very typical office building, for example. It's multi-story, and what I'm going to do is I'm going to go and I'm going to select this floor over here, and I'm going to request ProtaSteel. I'm going to request ProtaSteel to IntelliConnect to make the floor connections, the floor beam connections. And in this case, I'm going to use the fin plate connection rather than the stiffen end plate connection. And for the braces, I need to use the corner bolted gusset. I don't want to use the corner bolted gusset and then the bolted gusset if need be. So I want to use the corner bolted gusset first, and then the other one. Now let me just do this very quickly because I want to show you the copy feature, which is of interest to me. So this takes a while because there are quite a few connections in there. Maybe it's going to take about half a minute to a minute. But what I want to show you over here, these connections are made. You can make some manual modifications, and I'm going to show you some of that. But once you're happy with the floor and you've made your manual modifications, you're basically happy with the way the floor is. How do you copy, and how does ProtaSteel find the new floors and other places? Because some areas of the top floors might be different than the first floor. So it's basically going to look for the exact same situation, and if it finds the exact same situation, it's going to connect it. But if it doesn't find the exact same situation, it'll just connect whatever it finds, and that's going to be a huge advantage. So while it's doing that, let me just talk to you about some other things, some of the upcoming features which we have. What we're planning to do for this year is to improve the quality of the connection drawings, which we just saw in the beginning of the seminar. We want to make them so good that you have that they can be used directly, and there's almost like zero effort on your side to give the dimensioning of the connections, and the annotations look just the way you want them to look. So that's the whole idea, is to improve the quality of the connection drawings. Okay. Okay. Oh, okay, I see the reason. Actually, I had made the wrong. I'd chosen this shifted bolted gusset connection. That's why it's taking so long. So anyway, let me just show this connection over here. So we have these macros over here. For example, there are three connections over here, and the same situation exists on one floor above it. So one floor above it, we have the same situation. Yeah. So if I just right click and I say copy special linear, and I say 4,000 millimeters above that, and I say copy, it will give me a report, and it has found the new places at the top, and it is connected what was exactly the same, and what was different it has not connected. So because they had shifted at the bottom, that's why some of the connections are not made, but whatever it found to be unshifted, those were done automatically. So let me get back to what I was saying. What we do this here is to improve the connection drawings. Let me get back to this. Yeah. Improve the connection drawings. We're going to we're going to add a few new macros. So whatever macros you want, which you feel are not covered by ProtaSteel, you can let us know and we can add them. Like I said, mostly for 90% of the cases, you will have the connections already existing. And but for some, they might not be. You might be needing some very special connections, maybe some connections which are not in there. So you just need to let us know and we will add those connections. What we'll be primarily focusing on are the design reports. Well, that's what we want to finish as much as possible this year. And those will be the areas on which we'll be working on. I want to say that you might be wondering that, okay, these programs need to communicate with each other. So what if I need to make this program communicate with some other program? So what we have built into the software is an IFC integration. So you can use whatever you have modeled over here and send it to any program which accepts IFC input files. And you can also receive from programs. And another integration which we have done is the integration with Tekla. So the model structure can be sent to Tekla, and it can be modified over there or changed if you want. So there's a complete integration with Tekla, and there's a complete integration with any software which accepts IFC as input. So that's basically all I wanted to say today. So ProtaSteel basically prepares engineering drawings to facilitate shop drawing production for consultancy companies, prepares automated shop drawings for assemblies and parts at par with world-class software. It's general purpose modeling capabilities. It's truly BIM. It's fully interoperable. It's got new features like intelligent presets. I didn't have time to talk about those. It's got design overrides, which are a very useful feature, which we'll talk about some other time. It's got new connections. This is not mentioned over here that there's a new base plate connection. There's a new angle fleet connection, which is now going to be added. And there's the IntelliConnect feature, which you just saw how quickly you were able to finish the entire building in a few minutes, literally. The connection design reports are now there. They're coming in as we speak. We already have the basic simple connections, and hopefully by the end of the year, we'll have the beam to column moment connections coming in as well. And we have the interoperability with IFC and the Tekla interface. So this is what we wanted to talk about.